go ahead and wrap up your answers on the post-test. Make sure your name is on the post-test. Okay, and this just lets me know, I'm not taking a grade for it, just lets me know what you know and what you don't know, so we can make sure we get everything covered in plate tectonics. No school on Friday because the Wildcats, we're just determined we're going to go to state in basketball. So we're hopeful thinking you don't have any school on Friday. So don't come. I won't be here. No one will be here, okay? Huh? Monday we have school, but it's a short day.
Oh, because it's at March.
Because it's a teacher in service. So a little crazy. Okay, if I pass your pre-test, excuse me, to me. Just make sure your name gets on it. Okay, a little bit of housekeeping we need to make sure that we take care of. One, we're starting, if you didn't gather that from the announcements on the board, we are starting plate tectonics, okay? I'm very excited about this lesson. I know, don't groan, but of course, new lesson, new study packets. Yay, I know. I know y'all don't like them. But do y'all know that y'all's test grades are exponentially higher when you actually do them? Okay, I can tell you that. Statistically, increases your likelihood of a good test grade, okay? But the cool thing about this study packet is it is not due until Thursday. So you've got plenty of time to finish working on it. Y'all with me again? Okay. All right, so today what we're going to be doing is, so make sure y'all finish your study packets. It's okay. Did I just short you one?
No, I got it.
You got your one. Okay. All right, so today we're going to start on plate tectonics, and we've got a couple of different fun things that we're going to be working on. The first thing we're going to do is we're just going to have a great discussion about earthquakes, okay? So what I'm putting on the screen is a map of all the current in recent, the last 7 days, all of the earthquake activity in the entire world, okay? And what you're going to see on this map when it comes up is you're going to see little dots, okay? They're different sizes, they're different colors, okay? The size of the dot determines the area that was affected by the earthquake, okay, as far as the kilometers that it was affected. And the color has to do with the actual magnitude of the scale, okay, of the earthquake, okay? Yes?
Do you need the lights off for this?
Yes, that would be wonderful. Beautiful lights.
Yeah.
Corbin, you can get the lights on. All right, I'll pre-assign that to you. Yes, Corbin, do you have a question?
Yes. What isn't there is orange bigger than yellow, or is yellow like the magnitude was?
I'll explain to you the color system in just a second. So, but first let's just look at this, okay? So here's the map, all the earthquakes that have happened in the past 7 days. These are all 2.5 points magnitude or higher, okay? So that's their scale. We're going to talk about that scale in just a few minutes, okay? But what happens is, the first thing I want you to do is I want you to see where are we seeing and observing the most earthquake activity? Where are we seeing a lot of earthquake activity? Corbin.
Europe.
Okay, Europe, he says. Okay. All right, y'all get your bases here. Let's get our bearings. Y'all see Texas? Everybody know Texas? You're right here. Yeah, about right there. Okay. This is the whole world. Okay, so we're really tiny. We're over there. So that way we kind of get our bearings so we know where's Waldo. Okay. All right, Drew.
The Pacific Ocean.
Okay, this is the Pacific Ocean. Okay, what other things are you noticing? Tommy.
It's near Thailand and India.
Thailand and India, certain areas, certain countries. Wait a minute.
Right in the middle.
Right in the middle. You'll see that?
That's Hawaii.
Okay. No, there's no. That's water. There's no land there. Rihanna.
Like on the coastline of California.
Along the coastline of California. Mallory.
What you said? What do we notice from the picture?
Yeah. What are you noticing? Where are we observing earthquakes?
That most
Some happen near Alaska.
Some are near Alaska, quite a few around there. Drew?
I've got two things. There are none in Africa.
There's none in
And some of the
Africa.
earthquakes are like on the lines.
On those lines. What are these lines? Anybody know? Take a stab at it. Wait a minute.
But lake.
Those are plate boundaries. Those are the plate boundaries, okay? Those are not just random lines. They are important. So now, knowing that information, that those are plate boundaries, these lines, anybody noticing anything now about the earthquake activity? Does that change maybe your answer? Wayman?
On the plate boundaries.
Okay, Wayman says he's noticing a lot of earthquake activity along the plate boundaries, okay? What are some possible explanations for this observation of seeing a lot of earthquakes around the plate boundaries? What do you think's going on?
They push up against each other and make the wood go boom.
Okay, he's saying make the world go boom. All right, he's saying they're pushing up against each other. Zoe says they're just moving, okay? Corbin?
I think they're like rubbing against each other, like.
Okay? He thinks they're like, so more of this motion.
Yeah.
So Drew thinks it's this motion, right? Pushing towards each other, okay? And Corbin, you think it's moving like this, okay? And you just say they're moving. Do you have a...
They could be moving apart.
She thinks they're maybe moving apart is the reason that there's earthquakes, okay? So we have 3 different scientific theories going on in this classroom. Will we discover the answer before the end of the week?
Yeah.
Of course, Miss Mona, make sure you know the answer before the end of the week, okay? So, do all earthquakes occur on plate boundaries?
No.
Really? Why? What makes you're so adamant? Y'all were just so adamant about, no, that's not true. What proof do you have, Gabby? Yeah, if these little dots represent earthquakes, right? Gabby's like, Miss Bonine, there's no boundary there. There's no boundary right here, okay? Right? So some of them are on plate boundaries, but some of them are not, okay? So there's actually...
Just grew.
Do what?
It changed.
It auto updates. So there was a new earthquake. If we had a picture, we would have probably seen that there's new earthquakes. Every minute, earthquakes are happening.
Everybody goes,
So, whoa. Sorry, I didn't mean to startle y'all.
oh, 195?
So yeah, there's 195. I didn't see what it was before.
It was
But
167.
167. That's how many earthquakes happened in the last minute.
That's scary.
Yeah.
Scary. And the next thing you know, there's third rattle.
Okay, so back on task, okay? So if they don't all occur on plate boundaries, why? Why do some earthquakes happen on plate boundaries and some of them don't? What would be a reason for that, Mallory?
Because some earthquakes happen on plate tectonics.
Some of them happen because of the plate tectonics, okay? Drew?
Because that's the way God made the world.
That's the way God made the world. When in doubt, that's like because Mama said so, because God said so. But there's a scientific reason, right? We know that God can be evaluated through science always, right? Supported by that, okay? But I do like that because God says so. All right.
Because the plate tectonics have so much force that it even expands.
Okay, Gabby's theory is that because there's still so much movement and force happening that's causing things to go on inside the plate boundaries, okay?
So that's what we learned in when we were talking about the Earth. It said that the waves sometimes make
Okay, he's thinking because of the layers of the Earth, there's some movements going on inside the Earth and the waves.
like travel through
Because the waves traveling through because you're talking about what makes the waves travel through the, not silicon, but what makes the layers
the
of the Earth?
middle layer,
The cycle mantle.
Oh, and the convection current is what you're taking of, yeah. Okay. Guys, thank you.
Maybe it's happening in the body of the water.
Maybe inside the bodies of water, is the water causing something to go on? Lots of really good questions. We will discover the answer by the end of the week, okay? So, big question, do we have earthquakes in Texas?
Yes.
Yes?
Yes.
Really?
Yes.
Yes.
Who knew? Okay? So, let's look In fact, let's look at just the United States, and you will see that actually yesterday we had one near Dallas, okay, at about a 2.7 was the magnitude.
Is that good or bad?
It's a pretty small. In fact, I'm going to tell you here in just a second exactly how we scale earthquakes, okay? So we can see that we have them in Texas. Now looking at Texas compared to other states, what does our earthquake activity look like?
Small, very small.
Very small. What else? What else? Joshua, what do you think? What are you noticing from the map?
It's moderate.
It's moderate earthquake activity. What state are you seeing a lot of earthquake activity? California. Who? Anybody? Very, very exact. San Francisco. We're talking about a lot about San Francisco in just a few minutes, okay? Why does California have so many earthquakes, yet Texas has very little? Oh, I love the enthusiastic hand. Ooh, okay. Rihanna, tell me.
Because California is very close to
Okay, Rihanna stole everybody's joy. Good answer. Okay, yes, this is a plate boundary right there. And it's actually, Mallory mentioned this particular city in California.
San Francisco.
San Francisco, okay, and she said that there's a lot around there. Anybody know why there's so many? Okay, there's a particular thing that runs really close, okay, and it's a geological phenomenon. It's called a fault. I'll give you that thing, but it has a particular name. No,
I still know the name.
What's the name?
St. Andreas. No.
San Andreas Fault. Exactly, Noah. Shh. Guys, I'm sorry. I thought I was teaching. Thank you. We're not going to have that problem again, I'm sure. Okay, so this line right here is called the San Andreas Fault, okay? And the reason that California is having a lot more earthquake activity, because they are on a plate boundary, and they're getting a lot of movement going on that plate boundary, which creates a lot of earthquakes, okay? So we're going to watch a quick video. And I know all of you gentlemen were so excited because it says that we're going to actually look at some bombs. Okay, we're not really going to look at bombs, but we're going to watch a video called Tectonic Bomb. Okay, so now we're going to look at this video, we're going to talk, and then we'll continue talking about earthquakes in our discussion after you watch the video, because it may shed some light on some of the reasons that we have earthquakes, and then also some of the reasons that of different variations within earthquakes.
San Francisco is home to over 7 million people. They're all sitting on a tectonic time bomb. 2 big earthquakes, one in 1906, another in 1989, nearly destroyed the city.
There's a hell of an earthquake, and we've got windows and everything that's falling out.
The cost of the disasters, more than 3,000 dead, and over $6 billion worth of damage. Engineers in San Francisco are working hard to stop tragedies like this from happening again. An army of workers is improving bridges, anchoring homes, and upgrading the transport systems to make the city earthquake-proof. One of their greatest challenges is to build skyscrapers that stay standing when the earth moves. The tallest one in town is the Transamerica Pyramid, towering 850 feet above the city. Its skin is made of almost 4,000 glass windows and thousands of tons of concrete and crushed quartz. sheltering the 1,500 people who work in this colossus. They need all the protection they can get, as just a few miles away is the source of all the big earthquakes in San Francisco. It's the San Andreas Fault, the bane of California. A team of geologists is on a mission to track the fault with extreme precision.
This is an image looking down the San Andreas Fault with San Francisco located here. However, in just looking at this image, it's actually difficult to see where the fault might actually be.
The team's plane is equipped with LiDAR, a laser that scans the ground with an accuracy of 6 inches.
This laser shoots 100,000 shots per second and can be used to directly illuminate the ground surface by penetrating through the vegetation to show the ground surface below.
LiDAR strips away bushes and trees, even houses, to reveal the true landscape below.
When we overlay the LiDAR imagery that illuminates the bare ground surface, we can clearly see the location of the San Andreas Fault as this gash in the landscape that runs right next to San Francisco.
Two colliding continental plates create this tear in the landscape. Sliding on top of hot magma, they slowly crunch past each other. The landscape above breaks apart and forms the San Andreas Fault.
In this area, the Pacific and North American plates are moving roughly about 35 millimeters per year relative to one another. In some places, the San Andreas Fault actually moves continuously over time, whereas in other places, such as right here, the San Andreas is actually stuck or locked.
The continental plates never stop moving. So where the fault is locked, extreme tension builds up in the rocks. They bend and stretch until they shatter and unleash a barrage of shock waves, an earthquake.
San Francisco is in a little bit of a precarious position. You can't relocate a city. And so you just have to try and prepare the city as best you can.
Okay, so we can see now why we see so much earthquake activity. Why was the video called Tectonic Bomb? Why would he name it that? What's the reason?
Because when the fault is like rubs against each other, and when it gets locked in place, sometimes it'll take a while before it can move.
Yeah, think about, we talked a lot about this, we talked about forces. Think about if you're pushing something really, really heavy on the ground, okay? We all done that? Everybody's done that, right? You know what that feels like, okay? And you push, does it move initially? The first push, wait a minute, moves. You're just really uber strong. No, this is something heavy, right? Okay? Does it move when you first start pushing on it? No. What happens? Someone tell me, explain to me what happens. What happens? Got it. There's friction, and then eventually what happens? Does it just move really slowly? Or does it move kind of fast at first? Kind of moves fast, right? If I'm pushing it, I'm pushing, and then usually if it's really, really heavy, it kind of gives, right? You kind of feel like jerk, and it moves a lot, okay? That's what's kind of happening because of friction between the plates, okay? Right now they're kind of stuck. There's a lot of friction, okay? And they're stuck to each other. But is the pushing still occurring?
Yes.
Yes, okay? It's still moving, but it's just building up this force, and eventually the force is going to be more than the friction between the two plates, and it's going to move, okay? And so that creates a problem for California because they're expecting to probably have a fairly large earthquake, right? Is it probably very likely? What's the likelihood, y'all think?
Yes.
Yeah, it's really more like when, right? It's not if, it's when this earthquake is going to be occurring, okay? And so we can actually see that that we've got a lot of earthquake activity occurring along that plate boundary because of San Andreas faults, okay? Now, we saw that in 1989 there was a lot of damage that was created from earthquake in San Diego, okay? And so what are they doing now to adjust for that? What was the process? What are they going through and trying to do? Zoe? Exactly, they're trying to change the way they build things. That way when the earthquake happens, the buildings will actually be able to move, kind of sway, okay, when the ground starts moving. Now, we can think of some recently, can y'all think of some recent earthquakes over the last 5 years or so that you can remember that were pretty disastrous earthquakes that might have come to mind? One in Japan, that's an excellent example. Haiti. Now the one in Haiti really was a good, strong earthquake, but it was only about a 7, okay? It really wasn't that strong. Why was there so much damage in Haiti, where California can get earthquakes close to that magnitude and they don't have as much damage? Drew?
Because the buildings aren't built to sway, so like they just
Yes, exactly. The buildings are made out of cinder blocks. They're very brittle. And so what happened was when the earthquake hit, it caused a lot of destruction because their buildings were not built to handle that kind of condition. Let's see. Here's a picture of Haiti. Do y'all see all the buildings? These just basically like crumbled down when the earthquake hits, okay? So all of these are all buildings there were, okay? All of these were buildings, and now they're just completely flat. And so that's why the earthquake in Haiti was so disastrous, was because they were not prepared for such an earthquake with such magnitude with their building structures, okay? Now, does anybody tell me how do we measure the magnitude of an earthquake? Anybody know? What do we say? There's a scale that we use.
Is it a
So you're close. You're thinking about another word, okay? There's a scale, a name. It's actually a man's name that we use. Strip.
It's like the picture scale or the picture or the...
They're close. It's the Richter scale.
Oh,
Okay, it's
yeah.
called the Richter scale. And the Richter scale is how we measure, and actually what the Richter scale does is it kind of measures the magnitude based on how much destruction will take place, okay? So we can see here that the Richter scale, so anything from a 1 to about 2.9, generally not felt. So those happen all the time. Okay, anything below 2.9, we don't even feel. Like people in Dallas, they were there. The earthquake happened yesterday that we saw. Remember that? Remember the picture I showed you of the one in Dallas? Okay, they didn't feel that. Okay, there's more than 100,000 per year of those. Okay, all the time. We saw the number jumped on the screen, right? Okay, a 3 to a 3.9, that's considered minor. It's felt by many people, but no major damage. And those are 12 to 100,000 of those every year as well. Light would be 4 to 4.9. It is felt by all. And there's minor breakage of objects. So like maybe something fell off the wall, but nothing disastrous, okay? A 5 to a 5.9. Some damage of weak structures. And that's what we were looking at with Haiti. They had a lot of damage because they had really weak structures, okay? 200 to 2,000, anything between a 6 and a 6.9, those are considered a strong earthquake. That's moderate damage in populated areas because the buildings start hitting each other, okay? Major would be a 7 to 7.9. That's serious damage. It's over a large area, and usually, unfortunately, some loss of lives occur within an earthquake of that magnitude. 8 point and higher. It goes up to a 10, the scale. Doesn't happen, 10s don't happen very often. 8's pretty high magnitude. This is severe destruction, loss of life over a large area. Okay, so these are huge magnitude earthquakes. We don't see any. If you noticed, we go back to looking at our world and all the earthquakes that have occurred, you'll notice that most of them do not tap out above, like for example, this is a 5.5. That was your strongest that's occurred in the last 7 days, okay? So we see a lot of minor ones. We don't see as many of the larger on the Richter scale. Noah?
Like when I was at Dallas today, I didn't feel anything.
I know, you don't feel it, because it was the one in Dallas, I think we said, was it a 2.5?
It was 2.7.
2.7. So still, underneath that 2.9, you don't feel it. Okay, Mallory?
I have a question. My first question is it possible there could be a tsunami in San Francisco or something?
In what?
In San Francisco?
Tsunami earthquakes do create tsunamis. That's a great observation. Yes, but usually where do those earthquakes occur? Does anybody know? In the ocean. Yeah, those are usually earthquakes underwater that creates a tsunami. Okay. But that is a concern because there's so much plate tectonic movement around California, is that a tsunami would be created by the earthquake as well. So not only would the earthquake hit them, but it would create an aftershock that could create a large tsunami. So California definitely make sure that they're prepared as best as they possibly can for these major earthquakes. Yes?
Has there been any earthquakes higher than 8 in the past, like, say, 5 years?
No, I don't think so. Not that I'm aware of. Yes?
My second question was, what was the number for the earthquake that happened in Chile? I think it was Chile.
I don't know the exact magnitude. I'll look. I'll come back with it tomorrow, okay? I'll Google it and find out what exactly the magnitude of the one in Chile was, okay? But we can see that these earthquakes are constantly happening, okay? And we've discovered that a lot of these earthquakes can be accounted because of the fact of what type of movement?
Seismic.
Yeah, seismic, exactly, okay? So you mentioned seismic. Seismic activity is actually the waves, okay? And those are created because the plates are moving, okay? And so we'll talk more about seismology, okay, which is the study of all the movement in the earthquakes, okay, over the next few days, okay? Don't forget about your packet. It is due Thursday, okay? Now, today I'm going to give you, and we'll use the rest of class period working on this, okay? It's a student-generated model, okay? So what it does is it gives you, okay, an explanation of all the different plate boundaries, okay? And then it asks you to draw them, okay? And label them, okay? You don't have to be a good drawer, because everybody's like, I can't draw. Okay, it's like straight lines, okay? So you can kind of do straight basic neutrality. Now it does talk about a cross-section. Does anybody know what a cross-section is? Let's look. A cross-section would be like this, okay? So here's the crust, and here's all the earth, okay? And then maybe I drew a plate right here. Okay, that's a cross-section, okay? So it's just looking at the crust of the layers of the earth, and then I have the magma under here, okay? That's like a cross-section, okay? So we can clarify what that means, okay? So it's not looking at it from the top, okay? It's looking at it from, like, I could dig down and look on it from the sides. Does that make sense, okay? So when it talks about cross-section, I'm wanting you to draw the plates like you dug down, just like in that video. Did you all see where the video where it showed the San Andreas Fault and it took a corner out of the earth and you could see down? That's what I'm wanting you to illustrate, okay? Doesn't have to be great, okay? It does need to be detailed, okay? As far as I want you to label, think about how the plates are moving, and so arrows would be good, okay? And I want you to label things that occur on the plate boundary, okay? This is going to be huge for your test, okay? So, what you'll do is you'll take a large piece of construction paper, and you're going to divide it into about exactly 5 areas, okay? Now, my other class, I had people that did lines this way. I had some people that did like squares. You can do it however you'd like, okay? You can use your your own creativity to decide how you want to do it, okay? But you want to use up the whole piece of paper, so you have plenty of space, okay? That's why I got the big construction paper. And what you'll do is you'll read a little description about the plate boundary, and then you're going to draw it and answer the questions. So each plate boundary asks you some specific questions. You want to make sure your model answers those and shows those, okay? A lot of it has to do with the movement, what occurred on the plate boundaries, okay? So we're going to start this. You won't probably get very far, okay? I don't expect you to. I just wanted us to at least get started on it. And what we're going to do is tomorrow when you come into class, we'll be working in our lab groups, okay? Our normal lab groups. And we'll be going on to stations, okay? We have different stations I'll have set up here. And each station will look at a different process of plate tectonics so y'all can kind of discover how plate tectonics works, okay? So one of the reasons I gave you this is that some stations are going to take a long time, okay? And some stations are going to be fairly quick, okay? But we're all going to kind of move on the same schedule. Does that make sense? So about every 10 to 15 minutes, depending on how long y'all are going through a station, okay? So what do you think I want you to do with your extra time at the station? Sorry, what did you just say? Work on this, okay? You're going to work on your model. So when you finish at a station and you have time to kill, okay, you're going to work on this, okay? And that way, by the end of the week, you have an awesome study tool that has all the plates. And seems like such a great thing that maybe Ms. Bono would ask an essay question for you to draw a particular plate, right? And if you've already done it, isn't that much easier than trying to do it for the first time? Oops, I may have two. There you go. Make sure you put your name on the sheet of construction paper. I have rulers if you want to be very precise and draw nice straight lines. I do want it to be neat. It doesn't have to be perfect, but it does need to look neat. And for those of you, since I know some of y'all are like, and I love color too, and you're going to be labeling a lot of things. Sometimes it's nice to have multiple colors. So I have the Big Tub O color pencils, okay? So you can come grab some different color pencils for when you start drawing your plate boundaries. If you want to, like, do this brown and then do this red down here, okay? You can kind of color and show some contrast, okay? That'll help you with remembering it, okay? So we're going to be dividing it into 5, what the sheet says. It says to divide it into 5 categories, and then it's going to explain to you about the plate boundary, and then you're going to label it, okay? Draw it, label it, the cross section. And what we're going to do is you're going to have your name on the sheet, and I'm going to keep those big construction pieces of paper. You can take the packet with you, but you'll need it tomorrow, and I'll stack these up with the other classes. That way, since these papers don't travel as well, they're kind of big and bulky, they'll get bent. I'll keep them all nice here in class, okay? So you'll have it here tomorrow when we're moving our stations, okay? So you'll continue working on this all week. It'll probably take you the next 2 days to finish all of the plate boundaries, to draw them and label them correctly, okay? Any questions? No? All right, you should make sure that you've accomplished dividing your paper into 5 sections and labeling with your name by the end of class, minimum, okay? Most of you should be past that and be reading about the first plate boundary and be ready to start sketching it. You'll have about 4 more minutes. You're going to use the rest of the class to go ahead and set that model up.